Hello, in this video you will learn about potential energy. Potential energy is the energy stored in a body or a system by virtue of its position in a field of force or by its configurations. Examples: the raised hammer possesses potential energy, and the work is done by the hammer when its energy is released. In a toy car, the wound spring has potential energy as the spring is compressed and then released. Its potential energy changes into kinetic energy, which moves the toy car. Here in the diagram, as you can see that the spring is compressed and the potential energy is stored in the compressed spring. And when the spring is released, the potential energy stored in the spring does work on the ball and the ball starts moving. Now, there are different types of potential energies: gravitation potential energy, elastic potential energy, and electrostatic potential energy. We will study gravitation potential energy and elastic potential energy in detail in class 11th, and about electrostatic potential energy we will study in class 12th. So let's start with gravitation potential energy. It is the energy possessed by the body by virtue of its position above the surface of Earth. Potential energy is a scalar quantity. Suppose a body of mass m is raised to a height h above the surface of Earth against the acceleration due to gravity. Here, because height is not too much, so the value of g we have to take as constant. You will study in the gravitation unit that how the value of g varies with height. But here, because the height is not very large, so we have to take the g as a constant. The work done in lifting the body against the force of gravitation is given by, force into displacement. And here, the force means the weight of the body which you have to project. So it will be mg, and h is the height. So it will be mgh. And this work done is stored in the form of potential energy. Therefore, the potential energy will be denoted by the symbol U, and it is equals to mgh. Now, conservative and non-conservative forces. A force is conservative if the work done by the force in displacing a particle from one point to another is independent of the path followed by the particle and depends only on the endpoints. For example, gravitational force, elastic force, and all the central forces are the example of the conservative forces. The main point you have to take care is that for a conservative force, if the work done by the force in moving a particle around any closed loop, then it will be 0. Let's show the conservative nature of gravitational force. Here, consider a body of mass m which is required to be lifted up to a height h. So to prove it as a conservative, we will do it by two methods. First one, by directly lifting the body against the gravity. And let the height is h, and we have already calculated in the last topic that the work done in the lifting will be mgh. Now, by doing the same means we have to uplift the body up to a height h, but now through inclined plane, and the inclined plane is smooth, but the height from the ground is h again, as shown in the diagram. As you are pushing it up over a smooth inclined plane, you are applying force F, and the component of this one, the weights component, mg sin theta, will act vertically downward, and mg cos theta will act vertically downward, and mg sin theta will act along the smooth inclined plane, which is inclined at an angle theta with respect to the horizontal. And the value of theta in terms of sine, we can calculate that it will be the hypotenuse side will be equivalent to, what is the value of sine theta? You know that sine theta is the perpendicular upon hypotenuse. So the value of hypotenuse means the inclined plane distance which the body will cover will be equals to h upon sine theta. So the minimum force required to push the body is mg sin theta, and the displacement s, as I have explained, it will be h upon sine theta. So the work done will be equals to force into displacement mg sin theta into h by sine theta into the cos of the angle, and the angle between the force and the displacement is 0. So cos 0 will be 1, and you got the value of work done equals to mgh. So the work done by direct uplifting the object and through the inclined plane both have the same value, and you can see that it doesn't depend upon the path followed, it only depends upon the initial to final point. Now, non-conservative forces. The work done by a non-conservative force. If the amount of work done in moving an object against a force from one point to another point depends on the path followed along which the body moves, then such a force is called non-conservative force. The work done in moving an object against a non-conservative force along a closed path is not zero, because the value will be different by following the different path. For example, force of friction and viscosity are non-conservative forces. And note down these properties of non-conservative forces also in your notebooks. There will be some loss. As the heat energy is produced by friction gets dissipated and hence cannot be converted back into original form of energy, so we can't say that the work done will be zero. There will be net work done.